Hi everybody, welcome back once again to this channel. Thank you very much for joining us once again. We are still continuing revising the 2024 trial exam, and we are still looking at the Northwest Province paper, and we're going to look at this quite interesting question. It was question 11 on counting principle. So guys, if you're new to the channel, please make sure you have subscribed. Just turn on that notification bell so that you can be notified every time when we upload a new session. Without wasting any time, let's get into it. All right, so this is question 11, and we are given that two learners, one boy and one girl from each grade, grade 8, 9, 10, 11, and 12, are elected to form the grade representatives of the high school. 11.1, we are asked that, or rather we are told that when meeting, they start and end with a prayer, right? You know, with meetings, we are starting with prayer, we are ending with prayer. In how many different ways can they select somebody to start and someone else to end the meeting with a prayer? Okay, so to answer this question, obviously this is counting principle. We have to set our mind to be thinking about how many choices do I have. Okay, when we start a meeting, how many people are there? We have 2 people in each grade, 8, 9, 10, 11, and 12, right? So obviously the total number of people there are how many? 10 people. Okay, so when we start, how many choices do I have? Okay, so we can pick any of the 10 to start the meeting with a prayer. So when we begin, we have 10 choices, right? Then when we end, they are saying we have to select someone else. So it means the person we have selected here cannot be, who started the prayer, cannot also end the prayer. With the prayer, right? We have to select someone else. It means we have decreased our sample by 1. So it means that our choices now, we are left with the 9 people to choose from. Okay, so the total number of ways according to counting principle, it's we just simply multiply those choices that we have for the particular case. So it would be 10 times 9, which is 90 different ways in which you can select someone to start with prayer and someone else to end with the prayer. All right, let's quickly go to 11.2 now. So for 11.2, we are told that when they meet, they sit at a U-shaped table with the 2 grade 12 members next to each other and the 2 grade 11 members next to one another at the top of the table. Okay, so we are told that, you know, they sit on top, at a U table, and the grade 12 members and 11 members are at the top, right? And they are sitting next to each other. So let's assume those are grade 12s and these are what? These are grade 11s, right? So they've already shown you that they will be together like that, they are together like that. So they told us that the rest of the members sit on the remaining chairs in any order. And here is the question that has 2 marks, 11.2. It's saying determine in how many different ways can the members be arranged along the U-shaped table. Okay, so also here it's about how many choices do we have, right? So we have a restriction. The restriction is that the grade 11 and 12, they must sit on top, right? You know, if you are seniors in high school, you are given special position. Then the rest, your grade 8, 9, and 10 can sit anywhere beside, right? But the grade 11 and 12 on top, but they must be together, right? So obviously, if they have to be together, so we treat them as like one unit, because the grade 11s must be together, the grade 12s must be together like that, right? So we ask ourselves in how many different ways can we arrange those 2 units. You can either start with grade 12, then in grade 11, or you can shift, right? You can shift that to put grade 11s on the left and grade 12s on the left. So how many ways can you do this? There is 2 possible ways. Okay, so then again, don't forget, we go inside each unit and we check how many different arrangements are possible. So there are 2 people inside each unit for grade 12, they can be arranged in how many? 2 factorial ways. Similarly, inside the unit for grade 11, there are 2 people, they can shift position, right? So it means they can also be arranged in what? In 2 factorial ways. Okay, so then the remaining people, obviously you are left with 6 chairs, right? Obviously 6 people left, they can be arranged in anyhow, right? So 1 2 3 4 5 6, they can be arranged in anyhow. That will just be what? 6 factorial ways. Okay, so you can simply use your calculator to finally get the answer, and you find that, you know, there are really a lot of arrangements possible here. It will be 5,760 different ways in which they can be arranged. All right. All right, let's look at the last question. Quite interesting. It says they decided that during assembly, right, on a Monday, they will be seated on the first chair of each row for the first 10 rows. You know, in assembly, you stand in a line. You stand in a, I don't want to call it a queue. You stand like in a line. You understand, in rows rather. All right. So this class representatives, I mean grade representatives, they are saying, guys, we have, each of us must be seated in a chair in the first 10 rows, because there are 10 people, right? So row 1, row 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of them will be seated in the what? In the first chair in all of these rows, right? Rather, we can also represent it using just 10 chairs like this. 1 2 3 4 5 6 7 8 9. Let me just delete this. Okay, we have it like that, right? So I'm just indicating their first position in each row. So we consider this a row, like that. They'll be sitting in the first chair. Okay. So let's hear what they're saying. If they are randomly allocated seats, determine the probability that a boy will be seated in the first row, right? First row, there must be a boy, and another boy will be seated in the 10th row. So the 10th row, there must be another boy there. We need to find the probability of the chance. How likely is it that you'll find a boy sitting in the first row and the other one in the last row? So in counting principle, to determine the probability of an event, right, we say the number of favorable outcome, right? In this case, it's the number of desired arrangement divided by the total number of arrangements. Okay, so the number of desirable arrangements or favorable arrangement is that there must be a boy in the first position and another boy in the 10th position, or in the 10th row, right? So we ask ourselves, we have 10 people, right? Remember, they were selecting a boy and a girl in each grade, boy and a girl each grade. So because we have 5 grades, obviously we have how many? 5 boys and how many? 5 girls, right? So if there must be a boy in the first row, how many choices do we have? That's the question you ask yourself while answering a counting principle question. How many choices do I have in this particular space? So for boys, we have 5 of them. So any of the 5 boys can be seated there. So we have 5 choices, right? So if there must be another boy in the 10th position, I ask myself the same question. So one boy has already occupied the first row. How many boys are left to choose from? There will be how many? 4 of them. Okay, so the rest, they didn't tell us anything. It means they can be arranged in anyhow. So 2 people are removed from this list of 10 people. So the rest here, you are left with what? With 8 people that can be seated in anyhow. This can just be what? 8 factorial. Okay, so it means the number of desired arrangement will be equals to 5 times 8 factorial times what? Times 4. Okay, that's the number of desirable arrangement. So the total number of arrangement here, if we are to arrange them in anyhow without a restriction, here we are saying without restriction, Okay, total number of arrangement without restriction, just 10 people arranged sitting in anyhow in this rows. It will just be what? 10 what? 10 factorial. So you can clearly see that the probability here will be 5 times 8 factorial times 4, which is the number of desirable arrangement, divided by the total number of arrangement without restriction, which is 10 factorial. Okay, so we can just simply punch our calculator and check how likely is this. So I'm getting an answer which is 2/9. Quite very interesting. About 0.22, about 22% chance that you'll find a boy in the first row and another one in the last row. Okay guys, I hope you find this helpful, and I think this will be our last session for revising your trial exam. I hope you found the lesson very interesting. It has been a nice experience, and all the best, all the best. Don't forget to like, share, comment and subscribe. See you soon. Bye.